Hey guys, so this is the video for Lab 9. This one's going to be fairly short because we are providing these audio files to you as well as Audacity so you can do the analysis yourself. But I'm going to go through the lab manual just real quick here to give you a quick overview of what you're supposed to do and a little bit of explanation. And then I'm going to do some quick demonstrations in Audacity to show you how the analysis is actually going to be done. So most of this section of the manual is talking about the anatomy of the human voice and how it works. So we have our vocal folds here, down in here, that they vibrate together. And this creates a very broad spectrum sound, which can be tuned. It has a fundamental note. That's what you do when you're singing. But nevertheless, it produces harmonics across a very wide range. So you end up with a spectrum or vibration recipe that looks something like this, very broadband. And then by changing the shape of our vocal tract here, for example, by changing the position of your lips and your tongue within your mouth, you can change the resonances of this resonant cavity that it ends up changing the spectrum of what actually comes out with this sort of filter function. So a filter function in the electronic domain is like an equalizer, right? So a formant is essentially a specialized equalization curve that we can actually recognize as vowel sounds. And we have our first formant and our second formant here, right? So there's typically these two distinct peaks, and the position of those peaks defines the vowel that we hear. So here we have this sort of example plot of the first formant frequency, this one, and the second formant frequency, this higher one. And all these different words, they sort of occupy their own little blobby area here. So when we actually do the analysis, we have short recordings of each of these words, and you're going to sketch the waveform. I'll show you how to do that in a moment in the next video. And then we're going to take the Fourier transform of the vowel sound and locate our first and second formants and write down the frequencies, which, again, I will show you in the next video how that's done. And then finally, one of these recordings has the same word repeated over and over again, but the pitch is being changed. So essentially the guy is singing this word at different pitches. And you're going to sketch the waveforms and fill out this table. And that's really about all there is to it. So I'm going to move the camera over and take a quick video of the computer screen to show you how the analysis is performed, and that'll be it. Hey guys, so we're going to finish up Lab 9 here. I'm just going to give a quick demonstration of how to do this analysis in Audacity. So what we're going to do here is we're going to open up our sound folder, and we have this sound file for the word seat. And we're going to open that up with, let's see, select, open with Audacity. And you can also just open up the Audacity program and go to Open and find your file here in the File Explorer. And this all works exactly the same way on a Macintosh. If you have a right click on your Mac, you can do it that way, or you can do it through the File Explorer here. Whatever works for you. So we want to do this formant analysis, and the first thing we need to do is identify the different parts of this word. So to do that, we're actually going to listen to it.
Seat.
Now, let's listen to that again. That sounded a little strange.
Seat.
Now, this is interesting. There's an artifact here where there's a brief break in the word. Not sure what's going on there, not sure how that got there, but it's not going to stop us. We're still okay. We can work with this. Now, this region right here is very, very dense looking. That's because it has a lot of high frequency information. It's going back and forth very, very, very rapidly here, see? As we move along the time axis. That is the S sound. Any sort of sibilant sound has a lot of high frequency information on it. And that's why you'll often hear vocalists, when they're doing sound check, they'll make S sounds into the microphone to see if they can get it to feed back. Anyway, so we don't care about this. We've identified it. We're going to move on and look at this vowel region that we're actually interested in. So we can just click and drag to select, and then we're going to use the zoom button here. And now we can see we have a pretty nice regular wave shape that's being repeated here. So you're just going to sketch one cycle of this wave shape in worksheet 2. Once you've done that, we're going to zoom back out. We're going to select a region, go to Analyze, Plot Spectrum, and it didn't do it. I did that on purpose because I wanted you to see this. If you don't select enough information, the computer is going to say, well, this isn't enough data for me to do anything with, and it's just going to say, not enough data selected. So we don't want that. And what this is doing, by the way, is called a fast Fourier transform. I've talked a little bit about the Fourier transform in previous labs, like in lab 3, where we're converting from this time axis here to the frequency axis, and then we get a spectrum like this. As I've said before, it's not super important for you guys to know how to take a Fourier transform. You don't really need to know the math, but I do want you to know the term, because you'll probably encounter it out in the wild in industry at some point. So it's good to know, if not exactly what it is, then at least what it does. So now that we have our spectrum, I have this set up where my cursor, anytime it finds a peak, it will sort of stick to that peak. And we have a little box right here that says peak. And if we look at this, we can see this sort of envelope in the frequency domain. And these are this envelope function is our formants that we're looking for, just like I was talking about in the book earlier. So we're going to find a peak that looks like the peak of our formant, and this is at 293 hertz. So for the vowel sound in the word seat in table 3, you're going to write 293 hertz for the first formant. And then on the second formant, we're going to grab that right there. That looks like the top, and that is at 2060 hertz. So we would write that for our second formant. And then you're just going to do this for all of the other words that are listed. Not so bad, right? Well, we're not quite done yet. We also want to look at vowel sounds compared to pitch. And to do that, we're going to open up this seat song.wave file, and let's have a listen.
Seat, 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 seat.
Okay, so it's a guy singing the word seat at different pitches, and he's just, sounds like he's just going up the scale. I don't have perfect pitch, so I couldn't tell you what those pitches are, but he is just going up a major scale, I can tell you that much. So now we're going to select a formant and go to Analyze, Plot Spectrum, and again, we can see our envelope function which is our formants. So we're going to select this peak right here because that looks like the top of the first formant. And we have a first formant at 246 hertz. Right here, 246. So we'll write that for our first formant. And then our second formant, I'm going to call it probably here. And that's at 2,752 hertz. So we would write 2752 for our second formant. So this is great. You'll also need to write down the vowel sound. So it's seat, right? So you write down seat, the first formant, second formant. We still need to find the pitch. And to do that, we're going to go down to the bottom here. This first peak is our fundamental. And that is at 119 hertz, or A sharp. So it says A sharp right here. I'm not sure if I trust that, but that's what we'll write down because that's what the computer is telling us. And if we open up this next one, we're going to find our fundamental here. That's at C sharp. So, okay. Anyway, same process, find the formants, write them down. We also need to make sketches of the waveforms. So for our first pitch, we're going to zoom in and just make a sketch of one of these cycles, full cycle. Zoom back out. We'll look at this guy. Looks a little different. So make a sketch of this, etc. and so forth. Do it for all the pitches. And that's about it. There's not a whole lot to this lab. It's relatively quick once you know what you're doing. So I hope this has been helpful. Have a nice day, and I'm looking forward to seeing your results.